Hello my gorgeous friends of Webflow, it's your friendly neighborhood Francesco from Supasaido here. Today we're recreating award-winning animations in Webflow without writing a single line of code, and we'll push Webflow's native features to the limit. Again. You won't only learn a lot about scroll into view and while scrolling interactions, but you will also learn to see things from a different perspective and unlock more of both your and Webflow's potential. After watching and learning how even an award-winning website animation can be built in Webflow with no code at all, by only using a bit of lateral thinking and the native power of the platform, I'm sure you'll feel way more confident and enthusiastic, even if you have just started out. So, if you're looking forward to it as I am, stick around, and if you're interested in learning more about Webflow or no-code tools, check out our courses on Supasaido Academy. Link is in the description down below. And if you find my video helpful and want to support my work, hit the like button and subscribe to my channel. But now, if you're ready, let's dive in. When looking at the animation on the original website, we can spot at least 3 or 4 things that make it quite tricky and probably even a bit sneaky. 1. The transform origin of the images changing depending on whether they are scaling from the top or from the bottom of the viewport. 2. Regardless of screen size or aspect ratio, images start scaling up as soon as they scroll into view and scale down as soon as they scroll out of view. 3. Images scale in or out in a way that makes them stick at the top or bottom of the viewport until the scaling animation is over. How can we tackle these points? Well, let's start from what is actually the easiest thing to address, at least conceptually: the changing transform origin. How can we have an image change its transform origin depending on the direction in or out of the scaling animation? Easy peasy, we simply add 2 images, one for each transform origin. Making these 2 images work well together within the actual animation we're going to build might be a little bit tricky, but at least we already have one thing checked and a potential issue solved. And what about points 2 and 3? Well, here things start getting a bit challenging, and for this reason very interesting. We'll see that in order to tackle the last 2 issues, we'll need to see things from a different, probably a bit unconventional perspective, and be good at using and putting together absolute positioning while scrolling interactions and a bit of math. But now, without further ado, let's dive into Webflow. Let's start by adding a section and assign it the section class, though we're not gonna apply any specific styling to this element. This section will act as a placeholder for the content above the image gallery we're going to animate, so that we hide the image gallery below the fold, or we can say under the viewport. Then, as usual, let's throw a container inside the section and assign it the main container class that we will use to apply some padding. Let's say just 1 viewport width for the horizontal padding. Then, this time, we will also give the main container a maximum width of none. Inside the main container, let's add a div with the placeholder section content wrapper class. Let's set the display property to flex, align everything to the center, and set the height to 100 VH. Now, since this is just a placeholder section, we don't want to really spend much time on customizing it, so I'm just quickly gonna add an embed element where I will paste the SVG code of Supasaido's logo. Then, after clicking on Save and Close, I will give it the class placeholder section logo embed. Set the height to 25 VH and change the color of the logo to black. Placeholder section done. Now it's time to get serious. We have to start building the section hosting the image gallery that we want to animate. As usual, let's proceed step by step And let's first add a new section to our page and apply the section class. Once again, inside the section, let's throw a container with the main container class. And then, inside the container, let's add a div block and give it the gallery section content wrapper class. If we take a look at the original website, we can see that this content wrapper is basically a grid with 4 columns and a very small gap between 2 adjacent cells. So, to start with, let's set the display property of the content wrapper to grid. Then, let's set the number of columns to 4 and the gap to something like 0.25 VW. For this example, we're gonna use squared images, but later on we will see that this layout and the following animation work perfectly with images with all sorts of aspect ratios. Now it's time to populate the grid with images. I've already added a few pictures to my assets panel, but before we start throwing images inside the grid, let's first take a look at the original website to understand what sort of strategy we can come up with to properly fill the right cells. We can clearly see that inside each row there are at most 2 images. So not every cell is filled with an image and there are a lot of, let's say, holes inside our grid. Probably in a situation like this, the first thing we would come up with is, for the time being, let's throw all the images inside the grid and then manually tweak their position by using the grid child property. This is for sure a legitimate approach, but when we have a lot of images, manually placing all of them inside the grid can quickly become a nightmare. So personally, I'd like to adopt a different approach. What kind of approach? Well, we can simply think of the empty cells as empty div blocks that we can place inside the cells that should not contain an image. By following this approach, we'll soon realize that filling up the grid is a breeze. So, let's go. If we take a look at the original website, we can see that within the first row, only the first and the third cells are occupied by an image, while only the second and the fourth cells are hosting an image inside the second row. So let's first add one image to our grid, and let's assign it the gallery section image class. Let's use this class to set the width of the image to 100% and let's replace the image. Now, let's add a div block to our grid and let's simply assign it the gallery section empty cell class to clarify its role within the gallery. Then let's add a new image element, assign it the gallery section image class and replace the image. And let's also add a new empty cell div block to our grid. For the second row, we first need an empty cell, then an image, then an empty cell, and then an image once again. Within the third row, only the first cell is hosting an image. So let's first add an image, and then 3 empty cells. Now, because I think you already got the gist of it, I'm gonna pause the recording and I will add all the remaining images and empty cells and I'll get back to you. And we have it. The layout of our image gallery is in place and ready to be animated. Well, this is what I would like to say, but we actually still have a couple of things to do before we can start playing with the animation. For example, we mentioned that one of the trickiest things about the animation we want to build is that the transform origin of the images varies depending on whether they're scaling up from the top or from the bottom of the viewport. Also, not all the images share the same kind of combination of transform origins. And we also mentioned that this issue can be solved by using 2 images per cell instead of just 1. So the first thing we're going to do is duplicate all the images. But wait, now each image basically represents a single cell, right? So duplicating an image would mean actually adding a new cell to the grid. How can we solve this? Well, we could first wrap each image inside a div block that will take on the role of the grid cell and then duplicate the image. I'll show you how to do that for the first two images, and then, once again, I'll pause the recording and I'll repeat the same steps for all the remaining images. So, let's select the first image, right click on it, and open the Wrap In menu, and choose Div Block. Let's give this div block the Gallery Section Image Wrapper class. Finally, let's duplicate the image. Since we want only one image visible at a time, and later on we'll also want to be able to distinguish between the two images within the animation timeline, let's assign the first image the CC1 combo class, and then give the duplicate image the CC2 combo class, and use it to set its display property to none. Now, let's do the same with the second image. Right click on it, open the Wrap In menu, choose Div Block, assign this div block the Gallery Section Image Wrapper class, duplicate the image, assign the first image the CC1 combo class, and assign the second image the CC2 combo class. Now we have a duplicate for each image, but how can we assign a different transform origin to each of them? We need to use combo classes, and let's assume we want to use the first image when scaling from the bottom of the viewport and the second image when scaling from the top of the viewport. We can see from the original website that when scaling from the bottom of the viewport, the first image transform origin is the top left corner, while for the second image, the transform origin is the top right corner. So, we can select the first instance of the first image, assign it the CC top left combo class, and set the transform origin to be the top left corner. Similarly, we can select the first instance of the second image, assign it the CC top right combo class, and set the transform origin to be the top right corner. For the second row, it works exactly the same. So let's assign the CC top left combo class to the first instance of the first image, and the CC top right combo class to the first instance of the second image. Once again, now that you got the gist of it, I'll pause the recording and apply the right combo classes to the remaining first instances. Now, all the first instances of the images inside our grid gallery have the right combo class applied. And what about the second instances? Well, there's actually nothing different. So, let's just take a bit of time to understand where the transform origin is for the images inside the first two rows, and then I'll do the rest behind the scenes. If we take a look at the original website, we can see that when the first two images get to the top of the viewport and start scaling down, the transform origin is the bottom left corner for the first image and the bottom right corner for the second image. So let's select the second instance of the first image, give it the CC bottom left combo class, and set the transform origin to be the bottom left corner. Similarly, select the second instance of the second image, give it the CC bottom right combo class, and set the transform origin to be the bottom right corner. And what about the second row? We can see that the first image transform origin is the bottom right corner, while the second image transform origin is the bottom left corner. So let's assign the CC bottom right and CC bottom left combo classes to the second instances of these images. And now all the second instances have the right combo class applied as well, but the layout of the section is not ready yet. First thing first, very quick step. After adding the cc gallery combo class to the section. Let's set the background of the section to a blackish color and the top and bottom padding to 1VW. Then the elephant in the room. How can we tell the images to start animating while scrolling from both the bottom and the top of the viewport? We want a continuous animation, so we cannot rely on a simple scroll into view interaction. So we might think we can simply set up a while scrolling in view interaction for the images, but here's the thing. When we set up a while scrolling in view interaction, the percentage values we see in the animation timeline are based on the height of the viewport. But the height of our images, though what I'm going to say is not 100% accurate, is somewhat determined by the width of the viewport. And there's no straightforward way to compute the width of the images relative to the height of the viewport. For this reason, even if we manage to eyeball a value that could work for the device we're building the animation on, chances are that value will be completely wrong or anyway not 100% accurate for another device. This means we have to find another way, something that works no matter the size of the viewport, or, in other words, the aspect ratio of the device we're watching the animation from. Something whose height, no matter the size of the viewport, is always related to the height of the viewport. In order to understand what's missing and how to get it, we first have to really understand how the animation should work. And for this reason, after a long time, we'll be using a Figma whiteboard. Now, let's say this frame here is our viewport. And let's throw an image onto this frame. Let's give it a width of 400 pixels to start with, and position it so that its bottom border is aligned with the bottom border of the viewport. Let's also place a rectangle above the image that takes up the remaining vertical space within the viewport. Now, at the very beginning of the scaling animation, the image is not visible within the viewport, right? So let's group the two elements together and move them down so that the image is right below the frame. We now want that while the image starts scrolling in view, it starts scaling up. And we want the scaling animation to stop when the image is fully visible. We said it's not possible to determine the exact percentage for every device, right? But let's change perspective for a moment and let's take a look at the gray rectangle. The moment the image starts scrolling in view is when the rectangle is fully visible within the viewport, and the moment the image is fully visible is when the rectangle starts scrolling out of view. So, to start with, we could say that we could build a scaling animation by applying the interaction to the rectangle, and use Webflow's animation offsets to say the animation starts when the trigger element is fully visible within the viewport, and the animation ends when the trigger element starts scrolling out of view. This way, we can assign a clear meaning to the 0% and 100% values we previously saw in the animation timeline. But now you can ask, aren't we simply shifting the problem from one element to another? How can we compute the height of the gray rectangle in terms of the height of the viewport? Well, if we take a look at the whiteboard, we can actually realize that the height of the gray rectangle is by definition determined by the height of the viewport. Specifically, its height is 100 VH, so the entire height of the viewport, minus the height of the image. So here's the cool thing. Inside our project, the images are wrapped within a div block that of course have the same height of the image inside. If we set the position of this wrapper to relative, we can then throw a div block inside this wrapper. Give it the gallery section animation trigger class and set its position to absolute. This will be our gray rectangle. Now, because the image wrapper is the reference element for the absolutely positioned element, If we set the height of the absolutely positioned element to 100%, this will be equal to the height of the image wrapper, so to the height of the image. And because within Webflow we can now use the calc CSS function to compute complex size values, if we gave the gray rectangle a height of calc and within the parenthesis 100 VH minus 100%, we can make sure its height will always match our requirements. Now, in order to see something on the screen, let's also give the trigger a solid background color, kind of, and a width of 100%. But we can clearly see that its position is not right. We want its bottom border to be aligned with the top border of the image. For this reason, and because we'll see in a moment that we'll also need a second trigger positioned on the opposite side with respect to the image, let's select our trigger and give it the CC above combo class. Then click on the bottom option and then set the bottom offset to 100% to move the trigger up by an amount equal to the height of the parent container. Now, we said that we also need another trigger. Why? Let's take another look at the whiteboard. Similarly to the scaling up animation, we want that as soon as the image starts scrolling out of view, it starts scaling down, and we want the animation to end as soon as the image is completely out of view. So, for this reason, we can have another trigger whose top border is aligned with the bottom border of the image and whose height is, once again, equal to the height of the viewport minus the height of the image. By doing that, we can use it as a trigger and make the animation start, once again, when it's completely visible within the viewport, and make the animation stop when it starts scrolling out of view. So, back to Webflow, we can simply duplicate the above trigger, duplicate the CC above combo class, and give it the name CC below. Then we can pick the top option, set the top offset to 100%, and change its background color. And now it's time to start working on the animation. We'll see that after building this somewhat complex layout, building the actual animation will be pretty straightforward. Let's start by selecting the above trigger, navigate to the interactions panel, and click on the plus icon to add a while scrolling in view interaction. Let's open the drop-down and click on Play Scroll Interaction. Following the considerations we made when taking a look at the Figma file, we want the animation to start when the element is fully visible, and we want the animation to end when the element starts scrolling out of view. Then, we can click on the plus icon to create a new animation, and give it the name above trigger image scaling. Within the animation, we only want two actions for the two images inside each grid cell, one at the 0% keyframe and one at the 100% keyframe. So, let's select one of the two images and add a scale transform. Webflow will automatically create both the actions we need. At the 0% keyframe, the scale value should be 0, while it should be equal to 1 at the 100% keyframe. Now, if we take a look at the actual class we're targeting, we can see that this is the gallery section image element with the CC top left combo class. But we said we want to target both the images inside a single cell. To do that, we simply have to open the class dropdown and start typing image. And then make sure to select the gallery section image element, the one with no combo classes applied. We can also notice that we're only targeting the siblings of the trigger element, so only the two images inside the cell the trigger belongs to. Exactly what we wanted. Now we can hit save and, under trigger settings, select class. By doing that, we make sure that this animation will apply to all the above trigger elements within our gallery. So, all the images inside our grid will be properly animated based on their position within the grid. Right now we only have one above trigger, the one within the first cell, so let's copy paste it inside all the other cells as well. Let's also set its opacity to 10%, so that we don't completely cover the images that fall under the trigger. We'll get rid of the background color only at the very end, after all our tests are over. Let's now toggle preview mode to see what's happening. We can see that if we start scrolling down, the images get properly animated from the bottom of the viewport. Of course, regardless of the scrolling direction. And this is already pretty cool in my opinion. Now we're only missing the kind of symmetric or opposite animation, the one triggered by the below trigger, and that makes the images animate from the top of the viewport. Now that we already built the top trigger animation, taking this last step will be a breeze. We simply select the below trigger, navigate to the interactions panel, and click to add a while scrolling interaction. Once again, select the play scroll animation from the drop down, and make sure the animation starts when the element is fully visible and stops when the element starts scrolling out of view. Now, duplicate the animation that we've just built and give it the name below trigger image scaling. We only have to invert the scale transform values, 1 at the 0% keyframe and 0 at the 100% keyframe. Finally, after selecting class from the trigger settings, let's copy paste the trigger into all the grid cells and set its opacity to 10%. If we toggle preview mode, we can see that the animation that we've just built is not really doing its job. Why? Well, the answer is we're not animating the right image. Do you remember when we started building the layout and added a second image to each cell to account for the true transform origins, we hid that image, and so far we've done nothing to make it visible. So now we're always animating the same image, the first one of each cell, the one that should only be used for the first animation. So how do we solve this issue? To answer this question, let's first ask ourselves, what do we want to achieve? We want that as long as we're animating from the bottom of the viewport, only the first image is visible, while the second one is hidden. On the other hand, when animating from the top of the viewport, we want the first image to be hidden and the second one to be visible. When does the animation from the bottom of the viewport start? When the above trigger is fully visible within the viewport. So we can basically apply a simple scrolling view interaction to the above trigger to say, as soon as you scroll into view, show the first image and hide the second one. We can also observe that once this animation is over, the images inside the cell are at their full size, and the below trigger starts scrolling in view. So, similarly, we can apply a scroll in view interaction to the below trigger to say, as soon as you scroll into view, show the second image and hide the first one. With that said, select the above trigger and apply a simple scroll into view interaction to it. Let's open the first drop-down and choose Start an Animation. The offset has to be 0, since we want the animation to be triggered as soon as the trigger scrolls into view. Let's click on the plus icon to add a new animation and call it Above Trigger Scroll in View. We only need 2 hide show actions, one for the first image and one for the second image. So let's select the first image and add a hide show action and set its value to block. After opening the class dropdown, start typing cc-1 to make sure we select the first image regardless of the combo class it has been assigned to pick the right transform origin. Then select the second image add a new hide show action and set its value to none. Similarly, after opening the class dropdown, start typing cc-2 to make sure we select the second image regardless of the transform origin combo class it has been assigned. Finally, to avoid unwanted glitches during the execution of the animation, make sure to drag and drop the second action onto the first one to group them together. Now let's hit save and make sure to select the class option from the trigger settings. One thing to keep in mind is that we want this animation to play each time the above trigger scrolls into view. So we also need to somehow reset the interaction. Otherwise, Webflow will only play it once. In order to do that, we need to create a scroll out of view interaction as well. We don't need the scroll out of view animation to do anything, so we can simply create a completely empty animation. We're gonna use it only to reset the state of the interaction, so that the scroll into view animation is triggered each time the trigger element scrolls into view. So, open the second drop-down and choose Start an Animation. Click on the plus icon to create a new animation and call it Trigger Empty. Hit save and that's it. Now we only need to do something similar with the below trigger, but we already have everything we need. So let's select the below trigger and add a new scroll in view interaction. From the first drop down, choose Start an Animation and instead of creating a new animation, let's duplicate the one we've just created and call it Below Trigger Scroll in View. Let's open it up and we simply have to invert the two hide show action values. Then we can hit save, make sure to select the class option from the trigger settings, and after selecting Start an Animation from the second drop-down, select the empty animation. Now everything is ready to be tested. So let's toggle preview mode and start scrolling. We can see that everything is working great. Without using any code at all, we managed to perfectly recreate an award-winning website while scrolling interaction. Could you believe it? Now, final touches, live page inspection, and then we will see how we can recreate this same layout but in a slightly more complex scenario. Items from a CMS collection and images with different aspect ratios. So, first thing first, let's get rid of the background color applied to the trigger elements. To do that, let's select the above trigger and, after resetting the opacity, from the inheriting dropdown, select the base class and reset the background property color. Next, select the bottom trigger and reset both the opacity and background color. Now we realize that the trigger elements are actually clickable, and this might prevent the interaction with other content on the page. To avoid that, we can simply select one trigger element, open the inheriting dropdown, select the base class, and set the pointer events property to none. By doing that, we can make the trigger elements non-interactive when it comes to mouse events. Finally, let's duplicate the first section and put it at the bottom of the page so that we can completely scroll through the gallery section. So now, let's publish our project, go to the live page, and spend some time admiring our work. In order to apply this same layout to a list of items coming from a CMS collection and without using any weird workarounds, we need to adopt a slightly different approach and, once again, look at things from a different perspective. Otherwise, it would not be possible to assign a custom position inside the grid to every item separately. This time we will start from the final result, since most of the things are identical to what we've already built together, and I will explain all the differences step by step, to make sure you will understand how to adjust things on your own. So, without further ado, let's go! Let's start by saying that, of course, section and main container are exactly the same as before. So far, no surprises, right? Then, since we want to pull items from a CMS collection, we have a collection list element. We gave the list wrapper the gallery section list wrapper class, but we didn't apply any specific styling to this element. Then we have the list. To start with, we applied the gallery section content wrapper class we used in the first example, but as you can see, this time we also gave it the cc-flex combo class that is used to set the display property of the gallery to flex, the direction to wrap, since of course we want the items to spread out across multiple rows, and align everything to the top left. We will understand why we need a flex in a few minutes, but for now, let's simply keep in mind that by using a grid, there is no straightforward way to adapt this layout for items coming from the CMS. Then we have the collection item. Similarly to what we have done to the collection list, we started from the gallery section image wrapper class we used previously, and then we added a cc-flex combo class, this time to set the width of each item to 100% minus 0.75 VW, all divided by 4. But where is this value coming from? Well, 100% is the entire space available within a single row of our collection list. But that is not the actual space available to the collection items, since we also have a 0.25 VW gap between two adjacent items. So, considering that we want to display 4 items per row, we will have 3 gaps. Therefore, the space reserved for those gaps will be 0.25 VW times 3 equals 0.75 VW. And we then understand that the space available to the items is 100% minus 0.75 VW. Finally, since there should be space to host 4 items per row, the length of a single item will be 100% minus 0.75 VW, all divided by 4. Now, let's expand the list item to see what's inside. Here are both the above and below triggers, and nothing changed on their side. Then, we notice that this time the 2 images are wrapped by 2 custom elements. And they also have the img cover class, but that is just for responsiveness, and we'll take a look at that in a moment. Why are we wrapping the 2 images? Well, do you remember that the images inside the gallery in the first example have different combo classes based on the position of the transform origin? Of course, when it comes to the items of a collection list, there's no way we can assign different combo classes to the same element within different list items, directly from the style panel. As we all know, if we change the class applied to an element inside the collection list item, that change will be reflected on all the collection items within the list. But we have a secret weapon. Actually, 2. Webflow's custom elements and Webflow's custom attributes. If we wrap each image in a custom element, then we can add the class attribute to that custom element. What are we going to do with this class attribute? We're going to link its value to the image1 class name and image2 class name CMS fields respectively. Now it's time to take a first look at the structure of the CMS collection. Apart from the name, the slug, and obviously the image fields, we have these 2 image class fields we have just mentioned, and we are using them to store the exact same classes we are using for the images within the gallery of the first example. The only difference is that this time, the scaling transform is not applied directly to the images, but to their parents. One thing to notice is that in order to write the name of the classes correctly, we have to write all the various classes, so the base class and all the combo classes, by making sure they are separated from one another by a blank space. This is totally equivalent to assigning each image a different combo class depending on the position of its transform origin. And we're doing that to the elements inside a collection list and by putting together two of the most exciting Webflow's features, custom elements and custom attributes. Isn't it great stuff? We're almost done with the explanation of this new layout. We're just left with one question. How can we assign a custom position within the gallery to the items of a collection list? Inside the CMS collection, we can see we have a order field, but this is only a numeric field that we are using to sort the items within the collection the way we want, not to locate them in completely arbitrary positions inside the gallery. The key to this customization is enclosed in this code embed element. If we open it up, we can see basically two lines of CSS. With the first one, we are targeting the elements with the tag attribute, and we gave this custom tag attribute to the collection item, and assign it a value equal to its slug. By doing that, since all the slugs are different, we found a way to differentiate between the collection items. Back to our embed element, by leveraging the CMS binding, we are able to target all the list items separately, since this code snippet will be generated for each list item and every time the slug value will change accordingly. Then, we set the margin of each collection item. The first value is the top margin, and we want it to be 0. Then we have this kind of weird formula. Calc, and between parentheses, margin right, multiplied by 25% for the right margin. Then 0 for the bottom margin, and then another weird formula. Calc, and between parentheses, margin left, times 25% for the left margin. First thing first, let's say that both the margin right and margin left fields are number fields within the CMS collection. But how do we compute these values? Let's start from the first image. It doesn't have any space on the left, so the margin left is 0, but then we have one empty cell on the right, so the right margin is 1. Then let's take a look at the second image. Since the empty cell on the left is already been addressed by the first image, the left margin is 0. But since we also have an empty cell on the right margin is 1. And the third image, there's an empty cell on both the left and right, so both fields are equal to 1. And the fourth image, since the empty cell on the left has already been addressed by the third image, the left margin is 0. And because there are no empty cells on the right margin is also 0. Last example, fifth image. We don't have empty cells on the left, so the left margin is 0, but then we have 3 empty cells on the right, so the right margin is 3. You got the gist, right? Then, because each cell with the associated gap is equal to 20% of the entire space within a row, we multiply the value coming from these two CMS fields by 25%. And that's how we give a custom position to each element inside the CMS gallery list. Do you like it? Now, before inspecting the live page for the last time and then wrapping up, a quick consideration about the responsiveness. Making this layout responsive is pretty easy. In the tablet breakpoint, we can leave everything as it is. And actually, we can do the same in the landscape breakpoint as well. When it comes to the portrait breakpoint though, 4 columns are obviously too many. So, we can first select the gallery section content wrapper element and set the number of columns to 2. Then, since they're pretty much useless now, we can select an empty cell element and set its display property to none. If we now take a look at the second example though, we realize we have to follow a different approach. First, in order to remove the empty space between the images, we have to manually set both the left and right margin of the gallery section image wrapper element to 0, in order to override the value coming from the CSS snippet we added. Then, since we only want 2 images per row, we have to change the width of the gallery section image wrapper, and this time set it to calc and between parentheses 100% minus 0.25 VW divided by 2. 0.25 VW is the size of the single gap we have inside each row, and 2 is the number of items per row. We also notice that since not all the images have the same aspect ratio, there's some space left within the grid. To solve the issue, we first select the gallery section content wrapper element and make sure to stretch the content along the y-axis. Then, we select the gallery section image wrapper, that also has the CC Flex combo class, and set its display property to flex, to make sure the content inside stretch along the y-axis. Finally, to let the images keep their original aspect ratio, we apply this img cover class that simply makes sure the image takes all the available space within the parent element and sets the object fit property to cover. Finally, we can publish our project once again and take a look at our masterpiece from all breakpoints. And that's it. Today we saw how we can bring award-winning animations to life using nothing but Webflow's native power and a tiny bit of unconventional thinking. Of course, a link to the clonable for this project is available in the description down below. If you found this video helpful, don't forget to like, subscribe and hit that notification bell for more Webflow tips and tricks. Thanks for watching and I'll see you in the next one. Matane!